The next set of experiments that they carried out measured how much LDL bound to the surface of liver cells, how much LDL was internalized by the liver cells, how much LDL was broken down by the liver cells into the component parts, into the amino acids, into the cholesterol, into the receptors, which are then sent back out onto the surface of the cell. And then they measured what that did to the rate of cholesterol synthesis, but also what that did to the rate of LDL receptor number on the surface of these liver cells. So, as we could see, that in a wild-type individual, the more LDL that you put in its vicinity, the more you put in the Petri dish, the more binding there's going to be. Of course, there's not going to be any LDL binding if you don't add any LDL, but you also notice that there's only so much binding that can occur. So, after you've added a certain amount of LDLs, any additional LDLs are not going to raise the amount bound, so you've discovered how much can be bound to these cells. If you do that with the familial hypercholesterolemia cells, at least those in which this, it turns out, LDL receptor is entirely missing, you of course don't get any binding. What about internalization? Well, internalization fails to occur when there's no receptor. That might as well be a straight line at 0. On the other hand, the internalization is predictably rising as fast as it is binding. Hydrolysis, the breakdown of the LDLs into the component parts, rises quickly as the amount of LDLs are taken in normal cells fails to increase because you're not bringing it in the first place. It's hard to break it down. And then regulation. Regulation is measured as how much cholesterol synthesis is going on. We've seen the graph before, but here it is again. When there's an addition of cholesterol in this form through these LDL receptors, the wild-type cells now fail to make more cholesterol. And here, the FH individual cells continue to make cholesterol, no change. And that's because LDLs haven't been brought in, cholesterol hasn't been released, there's nothing to inhibit cholesterol synthesis.